We don't even think about it. When I focus on something up close, they work. When I'm focused on something far away from there, it just happens instantly. I don't even have to think about it. And you don't have to think about it either. As we get older, sometimes our ability to focus gets a little bit decreased, and sometimes we have to have glasses or contacts or something like that, or surgery to help us out. But this lens here is pulled, which makes it more elliptical or less elliptical, depending. And when it relaxes, there's also another set of muscles that pull it in, similar to what the iris has, but different as well. So this is how the lens works: thicker and thinner, to see up close and to see far away and all points in between. Now, the light wave image crosses through the largest part inside the sphere of our eye. And this is, again, filled with a different kind of pressurized gel-like substance. That is, inside this large ball here, inside of our eye, what happens is the lens actually crosses the image and throws the image of that pine tree back on the retina, which is back here. A camera works identically the same way, except the retina back here would be the film, which would be back in here. So if I put this back on here, screw it back on, then we've got a very good illustration of the way the eye works. It comes in there, it flips over, and lands upside down. So the trunk of the tree would be up here, and then it would land on the retina in this fashion. Now, our eyes, our brain, turns the image back around. But the retina is the curved back of the eye, and it is very complex. The retina is probably the most remarkable feature of the eye. It is unbelievably complex, multi-layered back of the eye that is full of light-sensitive cells, or photoreceptors. They're called rods and cones. You probably learned this back in school. Placed in a very precise arrangement, the rods perceive black and white and gray, and the cones perceive color. Now, if I told you that there were, let's say, 300 or 3,750 rods and cones, that is all the way back in here, the rods and cones. If I said there were 3,750 of them, you'd say, well, that's a lot. Well, that's not actually what they are. If I told you there were 375,000 of them, you would say, well, that is very impressive. But that's not accurate either. There are actually about 375 million rods and cones in one eye. One eye. Now, and they're arranged in a very, very precise manner. The combination of these 375 million rods and cones enable us to see nearly unlimited subtleties of color and contrast. Now, in order to achieve sight, each one of those 375 million light cells must have a direct optic fiber that connects back to the brain. Otherwise, if there's no connection, then there's no sight. Let me get something here to illustrate this. This is actually a power supply for a computer, but we'll use it just as an illustration. If this were the eye, let's say, and each one of these little outlets here, inlets, what do we call these, Jamie?
Inlets, I guess.
Inlets, I'm not. Jamie's a lot better. He's our cameraman. He knows more things like this than I do, a whole lot more. But at any rate, these all go to a very specific place in the computer, and this is a power module that the computer has to have in order to power all the various separate functions of your computer. If we were to if we were to disconnect, or just take scissors and cut all these lines here to the computer circuits inside, then there would be no functioning in your computer. That would end all functioning, right? Now, all of these are very precisely organized, as you can see. Now, there is nowhere near 300, there's not even 3,750 of these in this particular unit. There's nowhere near 375,000 of them. We have 375 million rods and cones. Every single one of them have to have a nerve fiber that is connected to a very specific part of the visual cortex in the back of the brain. Is it simple or is it complex? That's what we want to know. Well, I hope that you can see that it's complex. It's complex beyond your imagination. But now, listen to this for a minute. Most people think, and I thought before I began studying this particularly, that the nerve fibers came out the back, like the rods and the cones are right here, and the nerve fibers came out the back of the eye and came back to the optic nerve and went back like that. But guess what? It's not like that. It's not like that because God knew that each one of these rods and cones had to be fed by blood from the back of the retina. So what happens actually is the nerve fibers go inside and come along here, 375 million of them, imagine that, and guess what? They're all perfectly clear. They go on the inside orb of the eye, all back to the central optic nerve, and back to the brain back here, and nobody knows what happens there. Now, do you see there's so much more to say about that, but do you see a problem, potential problem, with the vision, your area of focus landing right here where the optic nerve goes back to the visual cortex? Do you see a potential problem with that? Well, I hope you do, because there is a potential problem with that, and that is where this huge cord of a bundle of 375 million optic fibers going back into your brain, wouldn't that create a blind spot? Well, the answer is yes, it would, and it does. It does create a blind spot. But there is an ingenious design solution to this problem, and that is the fact that the optic nerve, it doesn't actually come like I illustrated it here. I knew I was going to do this, but it doesn't come straight out from the back. It is actually lowered, and the optic nerve comes out down here and goes back to the brain, so that your central focus area, where you have the best, sharpest, clearest image, has no obstructions whatsoever.